Welcome back to Wowza Studio Sessions at NAB Show 2018. Now we're going to talk a little bit about low latency streaming and the trends that are developing in that area. I'm joined by two professionals from Wowza, Barry Owen and Jamie Sherry. Welcome, guys. Thanks for coming back on the show.
Thanks.
Absolutely.
Yeah. So let's just dive right into it. You know, the term latency is thrown around quite a bit, and you know, low latency is probably too often overused for a solution that maybe isn't. How is latency defined and measured, and what do we mean when we're actually talking about latency?
Yeah, it does get overused and it does get misused, right? We talk about latency, talk about low latency, talk about ultra low latency, and you know, it can mean anything from milliseconds to 30 seconds. So in our terms for our service, we're targeting 2 seconds end-to-end latency. That is
the coveted 2 second mark.
The coveted 2 second mark, which, you know, most chunk-based solutions delivered through CDNs are anywhere from, you know, 10 to 30 seconds of latency, and it's very difficult to get below that. So we're creating a platform to allow people to deliver low latency streaming as defined by that 2 second mark at scale.
Great, yeah. And so what are some different low latency streaming scenarios that end user might run into, developer, I should say, might run into that they need to apply this solution for? Because it's not always the right solution for everything. This, for instance, you know, this talk right now doesn't need a ultra low latency streaming option, but certain types of content do.
Yeah, that's right. So not everything needs it, as you said. Some people don't understand why they need it. They just want it sometimes. But the legitimate kind of business models or business cases or use cases involve things where it's highly interactive. And so the main thing I'd say is somebody is watching the video and listening and needs to type back to somebody or contribute to a conversation through, say, chat or other means. And the kind of the segments or areas that could apply is things like auctions or esports or sporting as well, true sports. Some gambling situations are coming online. More of these are coming online, and they're mission critical with latency because there's money involved or there's a timing aspect,
absolutely.
right? We talk about content abandonment in general, where people give up and they have zero patience for delays or buffering or problems, right? And that includes latency, where if the interactivity is so drawn out and spread out and slow, they're going to abandon it. So that's where it's highly critical.
Awareness of latency has certainly risen with, you know, the advent of more second screen usage and things like that, where you don't want to be watching something and then the Twitter feed comes in before you see the
Yeah, quite often it's earlier with streaming than it is with broadcasts,
yes.
right? Yeah, and that's something that a lot of people don't realize, and especially a lot of on-air broadcast engineers and stuff like that have a hard time understanding how we can deliver to the end user faster than they can via satellite.
Exactly.
Right. Yeah. So there's also a lot of issues around like bringing the traffic along with it, and what causes latency? What are the main causes for why something may be delayed that much?
Well, so the traditional streaming with RTMP was relatively low latency.
Absolutely.
It was delivered at scale, but it also required what I'll call smart edge servers, right? It's a bit stream, so it has to be streamed from an edge that knows what it's doing, managing the connections. With the advent of HTTP-based streaming and the chunk formats, the edges were able to get less intelligent. You could just have basically a disk pulling through chunks to the end user.
Less processing, repackaging.
Less processing, more scalable, right? You can pump out tons and tons of edges when you're doing chunk-based streaming. The most efficient way to do chunk-based streaming is time-segmented chunks.
Sure.
So chunk sizes of 2 to 10 seconds. Generally translates into about 3x that in latency at best.
And you can have a lower load on the servers that you're using because there's not as much intensive processing happening on the edge side.
Right, yeah. What I was going to add is the workflow for streaming, every component contributes some latency too, right? There's processing that involves latency. And there's this trade-off in buffering and having the actual content available, and the ability to provide that content, and that turns into latency at some point. You can't get down to zero is the point. You're going to end up with some sort of latency at some point, and it's just how along the steps do you try to minimize that.
Latency has its challenges in that, you're much more susceptible to stream failures and things breaking, and you don't have time to recover. If you're streaming something out with 10-second chunks and the next chunk doesn't download, you probably have time to go ask for it again and get it and recover before it's time to play that chunk.
Yeah, the error correction is a really fascinating thing for me, because trying to figure out how to regain and smooth those errors is always fascinating to me, because we're out in the field sending streams, and there are times where we could deal with a little more latency to ensure that all the chunks get there.
Absolutely, right? You increase some buffers on both sides. You do sacrifice some latency, but you're kind of proving that you're future-proofing your stream in a little bit of a way that it's going to get there, and maybe you don't care that it's 4 seconds instead of 2.
Yeah, absolutely. So, Jamie, what are some of the solutions that Wowza offers for low latency and ultra low latency streaming?
Yeah, so we've been, I call it many irons in the fire, dabbling in different ways with the products we have today. And so we started really with our Wowza Streaming Engine software and adding really two things there. One is a protocol called WebRTC, and it's actually a two-way communication protocol. Its original design, and people are starting to use it to replace RTMP in some ways, and use it as a combination of one-way and two-way streaming. And it's inherently very low latent. It's based on protocols that are like RTSP that are very low latent. And so that's one angle. The other is the
and real quick, WebRTC, for those of you who don't understand the protocol behind it, WebRTC is behind Skype, Google Hangouts, live stream interview mode, vMix call. It's used even in VoIP phones and things like that.
Yeah, it's used a lot, and typically for point-to-point kind of things, right?
Right.
And that makes it a little more difficult to scale. Mm-hmm. So people, again, they have to tackle that challenges, but there are people working on delivering WebRTC at scale.
Yeah. So beyond WebRTC, Jamie, you can continue with what else Wowza is doing in the low latency space.
Yeah, sure. So in Engine, the software we've added SRT as well. So there's an open alliance on this. It's a initiative created about a year ago, actually, and it's getting really good traction with a lot of vendors contributing to it, like Wowza. And we've added to our server software the ability to use this protocol as well. So SRT is secure, reliable transport, and it does exactly that, and that includes low latency there. So.
Right. And SRT, a lot of people think it's the future, or it's coming, or the adoption isn't there yet, but actually people are really using it at scale at a big level. I was just talking to somebody last night that was telling me about, they sat through the big SRT panel discussion with executives from ESPN and NFL, and talking about all of the different streams that are coming back from the games into New York, centralized for review of referees and things like that. It's a perfect use case for something like that, where they need to be able to turn around 32 cameras at a venue and get them back to New York, where they can be evaluated and then sent back to the tablet on the field, where the referee can review the play and stuff like that.
That was an interesting use case.
Yeah, absolutely. I mean, and they did it. That's the thing, is that SRT is, a lot of people are throwing that word around oh, yeah, we're going to have SRT, but,
they were able to do that over the public internet instead of having to have a dedicated fiber or some sort of satellite unclick or something.
Satellite trade-offs.
It saves them a ton of money.
So how does SRT specifically work well over public internet and unsecured networks as opposed to, some other options?
Yes, SRT supports, number one, it supports end-to-end encryption.
Right.
So you can
encryption
protect your
piece
content.
is huge, right?
For sure.
Yeah.
I mean, these people don't want their stream. They're not going to put their streams on the public internet if they're not encrypted.
Going over there.
And then it's a reliable UDP mechanism. So it essentially sets up a conduit for you to pipe a stream through, and it manages for packet loss, and it recovers, and it's a very intelligent thing, and it's the nice thing, it's open source. You can see how it works. You can dig into it. You can improve it if you want, and it's been really widely adopted.
Right, over 100 manufacturers, developers are part of the SRT Alliance now. We're seeing them all over NAB this year. It really is the NAB of SRT, I would say.
Yep.
You know, last year was all about IP video and, 360 VR, but we're seeing a lot of really cool, innovative transport methods this year. I think that's one of the coolest things that I've seen at NAB so far.
Definitely, yeah.
So let's move on to talk a little more about, the end player side and how things are accessed. So what I really want to know is Flash dead yet?
For a playback scenario, unless you're doing something highly custom, really it is. I mean, there's not a lot of support left in browsers. People are seeking out other options.
Sure.
Yeah, I mean, even Adobe says officially in 2020, Flash Player plugin will be done. So they're even, who knows if it'll be extended, but that's what they're saying right now, and that'll definitely end it.
So what's replacing it now, and what may replace it in the future? Is WebRTC a viable replacement for it?
It's one of the ways you could replace it for sure. What you're seeing with all the HTML5 players and things that utilize MSE in the browser is interesting ways to. I've seen people. Our low latency solution uses a WebSocket-based protocol. But we have an HTML5 player for it, the Wowza protocol.
Wowzockets.
Yes.
So what's a WebSocket?
So you begin with an HTTP connection, and basically what you allows it to do, it's called an upgrade. So you upgrade the connection, and it basically just opens a pipe that stays open. So you don't have to continually make more HTTP requests. So now we can send data down that pipe as a stream, much like you could with RTMP. And deliver that, and then we package that up and stuff it into MSE to decode the frames.
Brilliant. Wow. Yeah. What are some challenges involved in implementing WebRTC in a development pipeline from that regard?
There's a few. The standards, it's standards based, but the browsers have chosen in some cases some unique paths to implement the WebRTC standards, and so between Firefox and Chrome and not IE but Edge and all the popular browsers, you're seeing subtle differences that cause unique implementations to support those browsers. And the reality is, well, for now, Chrome is the demanding, most popular browser. There are others using other browsers, and so you've got to try to figure out ways to support them all, and you've got to subtly do things differently. That's nothing new, really, to the browser world. IE was really notorious for doing that as well with websites, but it can make it a challenge. And the other side of it is that WebRTC is not actually MSE based, and a lot of HTML5 players are. So if you're going to develop your browser playback application, you got to take a different approach than you would if you're going to do, say, an HLS or an RTMP implementation in the browser. And so you've got, again, forked kind of ways of supporting what you're trying to achieve.
Yeah, so how does that play out for the end user? Like, are there any specific challenges related to specific devices in servicing different apps on devices or connected TVs or anything like that with WebRTC?
Yeah, for sure. I mean, not all devices are going to support WebRTC playback. More and more are, but you're certainly going to run into set-top boxes and devices like that don't support it. With any solution you choose, you're going to be fighting that for a little bit, right? I mean, HLS and Dash are pretty widely accepted and playable in lots of places.
Absolutely.
Certainly HLS. Not as much with our WebSocket protocol or WebRTC.
Right.
I mean, one of the big things recently too is WebRTC is now supported on iOS, which it wasn't before. That was most popular operating system on mobile.
But wait, what runs FaceTime?
I don't know. Yeah,
no,
there's a difference between private and public, I guess.
They won't tell.
They won't tell us. That's why we can't use it for broadcast. That's one of the things that we hoped for years. We always get requests like, "Can we use FaceTime instead of Skype?" Sorry, we don't have the way to interact with it.
Yep.
Yeah. So it's interesting. So what are some other ways in which Wowza supports WebRTC in engine, cloud?
So WebRTC is an engine-only feature right now.
Okay.
We will likely support SRT ingest across cloud in the relatively near future. Our sweet spot, I would say, for the engine use case is WebRTC in, and then either traditional out to many people or WebRTC out at scale as well. You'll have to build your own network to do that because you're not going to run 10 million WebRTC users off one streaming engine. You have to build your own little WebRTC CDN.
Yeah, yeah. Are you able to peer assist delivery with WebRTC? Is there a way to jump it? I'm just spitballing here because typically WebRTC is point to point.
It
right?
is peer based, by default. Yeah.
So is there a way to utilize that to scale WebRTC?
So that there are clever uses of WebRTC technology, but for now they've been focused on traditional streaming. So like the stream routes and the peer 5s and those kind of folks who are doing the peer assisted delivery are typically doing peer assisted delivery of chunk-based formats. So what they're doing is kind of creating their own edge cache within a set of peers and being able to share the chunks between those peers.
Sure.
Which is it's a really cool idea, and it's very efficient in certain situations. And they actually use the WebRTC data channel to orchestrate all that and to share the chunks. But it's not WebRTC delivery per se.
Sure, yeah. So there's low latency options, there's ultra low latency options, and it sounds, you got to go somewhere with the language, I guess, and ultra makes sense, I guess. So how does Wowza deliver its new ultra low latency service, and how is it working with Microsoft to deliver those across global networks?
I'm going to let you take that one first.
It's me?
The product guy.
Yeah, so when we talk about ultra low latency, we're trying to get down into this service offers sub 2 second. We started with an idea of trying to get below 3 seconds, 1 to 3 seconds, because that's what Flash and RTMP could do in a lot of cases. And so we got sub 2 seconds. We also decided and really see value in providing the scale aspect to this, and so it's a service, and you may see it in engine in the software in the future, but for now it's a scaled service as part of the cloud, Wowza Streaming Cloud, and it's because of the scale and the performance that we think matters, right? People want to not only get this out, but get it to large audiences with that low latency in place like they do with HLS and other higher latent formats. And we've chosen to put this on top of the Azure cloud today. All the cloud service stuff we have today is in one of many clouds. We try to be as agnostic as possible, but this one is on exclusively on Azure today to take advantage of unique things over there, and that includes the people and the resourcing over there. We really have a good relationship with Microsoft, and have worked with all the teams over there in engineering to really build this service out the way it is today.
Yeah, Microsoft's been a great partner with Azure, and Azure has provided us a stable platform that they have really high performance networking. So, by using them for our delivery, we're not injecting latency due to network issues and other things. So they've been great to work with. They're super helpful, and it's nice to have a strategic partner at that level to go to market with.
Yeah, I mean, it was very interesting. We had Microsoft on and talked with them a little bit about that solution, and I found it pretty fascinating. How has the landscape sort of changed over the years to include more and more user-generated content, implementations, and various apps and services that will really take advantage of lower latency option?
The example that always pops into my head right now, just because it's so popular, is look at the HQ Trivia app, right?
Right.
So that requires low latency. They're talking, they're interacting, the users are participating at the same time. I think you'll begin to see more and more use cases like that. It's been really interesting about the shift to mobile versus desktop. Some of our biggest customers are mobile-only customers at this point, and they're doing interesting stuff like HQ Trivia, and we have people doing auctions, and certainly Jamie mentioned, gambling and things like that, where the latency is critical to that piece, and the bulk of those tend to be mobile focused.
Yeah, yeah. Another scenario where ultra low latency is really important is in the esports space, and a lot of that can be considered under the umbrella of live UGC content. And how is Wowza using certain low latent technology to deliver live UGC content to end users that or to giving them the developers the tools to make that happen?
Right. Yeah, with the mobile space that Barry mentioned, the most popular way to support people is with native apps versus the browser. It does do both, right? And so we have our Wowza GoCoder SDK, which historically has been a capture and publish SDK framework to build apps to do those things for live streaming and publish into our engine software, our cloud service. And recently we've added support for a playback aspect as well. So now people can build these mobile apps and incorporate the low latency streaming aspect of what we provide into the apps and the user experience that they're building in those native apps, and get those out the door to support the esports or the auctions or whatever they're doing, where mobile is the primary way that people will consume the content.
Right, and mobile content is very difficult to deliver because you're dealing with very unpredictable cell environments, and
Right.
whether
Wi-Fi,
it's Wi-Fi, 3G, 4G, maybe 5G, is coming. But how is Wowza helping deliver to those poor bandwidth environments, especially in mobile apps?
Yeah, so I think SRT really can help us there.
Uh-huh.
I think especially on the contribution side, where you're sending a stream out from a phone or a mobile device to the cloud. Doing low latency on a mobile device with good playback is really hard. There's lots of things that can go wrong. So
Sure.
by controlling the service, by having deep knowledge of the WebSockets that we use, the protocol we use, we can recover from a lot of those things and be clever about how we'll try to play the stream back, and we'll continue to advance that. And whether it's using things like SRT or other alternate delivery mechanisms to and from the phone, we'll keep poking at that until we get it right.
Yeah. What do you see coming in the near future for mobile content delivery, and especially in different types of content that may be created for low latency optimization?
Barry.
So, typically the phones have been they obviously iOS's native format is HLS, and they're good at that. So, but now you are seeing support for things like WebRTC and other stuff on the phones that are inherently low latency ops, and it's still the Achilles heel, if you will, is still the network connectivity things. So you can start to look at alternatives and can you do multipath TCP or something interesting to try to bond things even on the phone itself to kind of eke out more bandwidth. Can you optimize your streams so they look really good at low bit rates, so
Right.
that
Yeah.
you're going to get some level of playback. Can you be intelligent when you get to the point where, okay, well, I'm not going to be able to give you decent video. I'm going to drop the video and go audio only. Sorry, it's the best I can do.
Yeah. And in a lot of cases, that is, especially when you're dealing with an app that relies on low latency, that is the best way to go. If the bandwidth drops below a certain level, you can tolerate dealing with the audio-only stream and still getting the content in time. That's really important.
Yeah, with mobile too, you have sensitivity to battery life, so you got to be cognizant of that, and there's people are looking at ways to optimize that. And I think that in addition, you're going to end up with a multi-protocol path, getting from point A to point B, whether no matter what point B is versus A, you're going to see SRT come in, and you're going to see something in the middle be different than that, and then you might see something on the outset that is, like you're saying, with some of the other protocols.
What are some of those alternate protocols that may be used in the middle?
Yeah, a lot of people are starting to look at a protocol from I believe it's Google for Quick, right?
Uh-huh.
Is one of them. So QUIC.
There's different things you can do to kind of optimize your network stack and optimize all the things. So there's a thing called BBR, which is really just a better congestion control algorithm that we can deploy on our edge servers to help eliminate the drift of the streams and keep everything stable by the time we're delivering it to you. And then on the phone, like Jamie said, there's, the nice thing on the phone is you're not tied to the browser necessarily if you're going to write an app.
Right.
So there's no reason you couldn't do SRT to the phone as well. It's UDP based, and it's
because only the app has to support it.
Only the app has to support it. So you have a lot more options on mobile, which are going to be interesting to explore. And we will add SRT to GoCoder for sure for contribution, but we take a look at it for playback as well.
That's awesome. That's awesome. Guys, this was great talking low latency streaming with you. That's all the time we have. For Barry Owen, Jamie Sherry, thanks a lot for coming on. I'm Rob Baynard with LiveX, and we'll be right back for our final segment of NAB Show 2018, the LiveX Happy Hour, where the LiveXers are going to get on stage and kind of recap the coolest things that we've seen so far. So stick around. We'll be back at 5 p.m. Pacific time, and we'll see you then.
Thanks.